Hey everyone, today we are going to be looking at the Roland JP-8000. This synth needs a little bit of repair. That's a very common problem with everything, at least every JP-8000 that I know of, which is it's going to have low audio. So the symptoms you'll have is first there'll be no audio out of the two main left and right outputs, followed by later the output will also fail in the headphones. You'll see a lot of these for sale for cheap because there is no audio output. Everything else appears to work, it's just the audio is very weak or very low. So the cause of that is simply because of the capacitors on the main board go bad. I did a separate video about the Roland XP50, which had the very similar problem. Symptoms on that were low audio out the outputs, and actually the display would fail on that due to the caps going bad in the main board too. So this synth is no exception. It's got the exact same problem. There's thousands of these out there that have the same problem. If you own one, it's going to have that problem. If it hasn't yet, it will probably soon. These came out in 1997, so around 30 years old at this point. They're getting up there in age, and the capacitors that were originally spec'd for this unit, just weren't designed to last that long. So I've talked about in the XP50 video as well, what the grade of caps they were in here. They're SMD electrolytic caps that are on the main board. And I don't know if they were 85C rated, I don't know if they're 105C rated, I don't know what the manufacturer was, but on this series of Roland gear you're going to have this problem. If it hasn't happened to you now, it will in the future. So this synth I actually also bought from Japan. So this is a 100 volt unit. To test it, I've got it hooked up to the Variac on my bench at the 100 volts so that I can test it and verify that it indeed does not have audio on the output. But part of this video too is I'm going to be converting this unit to 120 volts. It's extremely easy to do. I did a separate video on this as well. I'll link it in the comments down below. But another thing to watch out for too, because there's a lot of these for sale in Japan, and they're cheap even with shipping. It's about $100 to get it shipped here. It took about 3 weeks roughly, so I had time. I wasn't in a hurry. It wasn't a very big deal. So watch for those there too, because the 100 volt units, even though they're 100 volt, they're easy to convert to 120 volts. So you can use it here in the US. Or convert it to 230, 240 volt if you're in Europe as well. It's just as easy to do. So the JP-8000 is a pretty unique synth from Roland. It was kind of their return to the hands-on, idea of adjustment of all the parameters of the actual synth. Going back their legacy of the famous Junos and Jupiter series of synths. After the Juno 106, which I believe was the last analog synth that still had the the full control of all the parameters on the front panel there, versus the Alpha Junos and synths that followed it later, which were controlled through a digital interface, which was always cumbersome to do, and the programmers were designed that you could buy separately to make it easy to program again. They kind of went back to the design of all the controls on the surface of the synth, which was pretty cool. So the JD800 actually came out early 90s before this, and that was still a digital synth. Was based on ROM playback, or is based roughly on the D series, I believe, that gave you some of this control. But this JP-8000 was the first analog modeling synth. That is, they're actually, with the SP modeling the actual analog waveforms and allowing you to control everything in real time. So I actually still have a Roland catalog from 1997, and you can see on the very first page when you open it up was a JP-8000, because this was still kind of their flagship model at the time. 8 voices of polyphony, all sorts of real-time control. You could split the keyboard up into 3 separate areas. Lots of fancy features, and of course the famous supersaw waveform, which this came with, which basically was extremely popular with trance music. So a lot of people kind of give this synth a bad rap because they think it's very one-dimensional. You hear the typical trance-type sounds that come out of this, and they think that's all it can do, but it's actually a really, really powerful piece of gear. It's capable of much more than that. We've got 6 different waveforms plus noise, and it's a fun synth to play with. So one of the main reasons why I want to get this one going. So in this video we will tear it apart. We'll take the main board out. We'll replace all the capacitors on the main board, put it back together, do the voltage conversion, and while we're in there we'll kind of take a look inside and see what Roland was using on the internals of this, kind of like a mini teardown. We'll take a look and see what digital analog converters are using, along with all the other components they have possibly spec'd. So I got the synth upside on my bench. I got a towel just so I don't scratch it if it happens to rest on there. I've got foam blocks supporting it just to keep all the knobs and pitch bend and everything else from resting on the bench itself, which could damage it. With most Roland gear, you pull every screw off the bottom. This one's no exception. 20 some screws on there, and the bottom should just lift right out. So build quality of the synth is mostly plastic. Actually, it's entirely plastic all the way around the entire frame. You have a metal key bed, but the entire body itself is plastic. And then the bottom is actually some type of pressed like fiberboard, wood basically. So this isn't an extremely heavy synth. I think it was kind of designed to be portable and a little bit lightweight for people that want to take it with them. But yeah, it probably wouldn't survive a drop, I'll say that. I'm sure it would get pretty damaged pretty easily. So anyway, we're inside. And looks pretty standard Roland in terms of build construction. So key bed along the front here. This is going to be our main board under all the shielding. This is what we'll be removing and replacing caps on. You have your audio and jack board on the back here. So this is your foot pedals, your audio switches, along with your MIDI ports as well. Power supply over here, your classic standard Roland linear power supply. A couple linear regulators, and a transformer that Roland's used for probably, I don't even know, 20 years or something like that. Along with your input filtering. So small board over here for some of your controls, and then your pitch bender. So along with two separate boards on the back for all of your control surfaces, all your knobs and your push button switches. So for this repair, you really just need to focus on this board. So I'm going to remove this board and this board alone. Everything else in the synth is good. All the keys work. When I initially had to power this up again, I had very light audio out of the headphone, just enough to verify that everything worked on it. So I'm just going to be tackling this board for this repair. And for anyone that has the same audio problem, this is the board you're going to want to target for the cap replacement. Alright, so once you remove the top shield, you can access some lower screws on the board there. You can pull that out. When you're doing this capacitor replacement, always remove the board from the unit. It's just too difficult to get down in there and actually do this reliably in terms of all the number caps on here you have to replace. So I will set the synth aside and we'll work on this board. So here is the main board out of the JP-8000. Very similar design to most of the Roland boards of this era. Very similar to the XP50, which came out around the same time as the JP-8000. What we're going to be focusing on is the capacitors within this unit, specifically electrolytics, which are these little metal cans here. So there's 20, 25 of them maybe total on this board, and the ones in question that are causing your low audio output are in this area right here. Our DAC lives over here, along with some op amps for the actual audio output, which actually feeds out of this connector here to our analog board, or our jack board. And these are the ones that go bad, that actually are causing the problem of the low audio output. So on some units that are a little bit older, you actually see these leaking. This unit doesn't look too bad, which I'm good with, so I'm happy about that. But even though these caps here are the only ones usually causing low audio output, you want to go through and replace all of them, because they're all going to be exposed to the same heat. They're all the same age. They've all reached their lifetime of usability. So even if you solve the audio output problem by replacing a couple in this section here, these other ones are going to continue to fail. They're going to leak in the board, damage the board, cause other problems along, in the unit itself, and just be problematic down the road. So if you replace them all now, you'll get another 30 plus years out of this unit, ideally, at least in terms of problems with this board here, which is the most common problem you have. So the caps I'm going to be using to replace the ones on this board are made by Panasonic, specifically the EEE-FC series of 105C rated caps. So these caps are rated 105 degrees centigrade or Celsius at 1,000 hours. Much higher rating than typical 85C caps you have. Again, I don't know what the spec of the caps on this board is. I'm guessing they're probably only 85C rated. That's typically what most manufacturers use because the 105C rated caps are more expensive. I mean, that said, the cost of the caps on here to replace this board is probably $20 roughly. I purchased all these from DigiKey, and I always purchase them in bulk just because I do so many different things with them. You get a price break on that, so it's probably only $10 realistically worth of caps for me to replace everything on here with these 105C rated caps. So one of the first things I do anytime I'm doing a repair like this, especially with these SMD caps, is I take a picture of the board and I leave that up on the display at my bench. Specifically because as you're going through and you start replacing these, it's very easy to forget the orientation of the caps. These are all polarized caps on this board. Now the board does have some markings that indicate, which side, ground is according, on these caps themselves. But it's still really easy to make that mistake, especially in the tighter areas where that little line, little mark can be hard to find, in between all the silkscreen for the other components on the board. I'll start in groups. I'll do a lot of the same values. So over here we have multiple 10 UF and 16 volt caps. I'll probably do all of them at once and then work my way across the board as I go. You have another one hiding over here too. So everyone has their favorite way of removing these caps on a surface mount board like this. I'll show you the way that I like to do it. And this way minimizes board damage. A lot of people like to just twist the cap off or break it off or try to desolder with the vacuum. I think this is the easiest way without doing any damage to the board. So take your iron, nice blunt tip, set it right next to the cap till you get the solder really hot in that pad, and then simply nudge the cap. What it'll do is because it's actually melted there on the pad, it'll nudge the cap over, removing it from that side. Then you do the same for the other side, nudge it, and then the cap will basically just fall right off the pads. And once the cap is off the pads, you can go through and clean that up with some solder wick. If you have boards that have been damaged because of leaking caps, a lot of times these traces can be a lot more fragile, which is why I like this method. Using excessive force on it can really damage the pads itself on the board. Once the solder is gone, make sure you go through and you clean up any traces, electrolyte too, that's been leaking, just to make sure that it doesn't cause problems down the road. So here are the first 4 caps that are removed. 1, 2, 3, 4. You can see the pads on there are in really good shape, and then you can see the negative markings on the board as well, indicating the polarity for each one. For installation, I like using reverse locking tweezers, because you don't have to worry about your hand tension getting fatigued and dropping a component. It makes it really easy to hold the caps this way. Alright, first 4 replaced. We will continue our way across. Alright, so capacitor replacement's done. Here are the old caps. All the new caps are on the board. It took about 30 minutes or so. It wasn't too bad. There was decent spacing on these too, which makes it getting in there with the iron pretty easy. When you get them really close to the plastic connectors and stuff, you have to be careful, because it's really easy to touch the iron on those and start melting them, which you don't want to do. So, nothing else left to do on this board except for replace the battery. If it hasn't been done, you might as well do it while you're in here. There isn't any presets on this that I care about in terms of some that the previous owner may have put on there, so it's not a big deal to me. So battery just pops out. No soldering. It's just a standard CR2032 cell that you replace it with. So Roland nicely enough socketed it on this unit. A lot of the gear it's soldered in, which isn't a big deal, but again, it's just another extra step you have to do to replace it. So next we will take a look at the hardware of this board, kind of see what makes it run. As far as what we can tell, Roland stuff is usually pretty proprietary. And then after that we'll look at the power supply, because we have the voltage conversion to do on that as well. So here's a look at the main board on the JP-8000. This is typical Roland construction, where they have a lot of their own branded chips. Specifically looking at this board, you've got these 4 Roland branded chips here, which are labeled R008925556. So basically no information available out there about those. So best explanation of what they are is simply the DSP for this unit, for all the analog modeling. So they're probably some type of custom ASIC that they had, made in-house and then had someone fabricate. Pretty neat to see on this. No idea what the specs of them are, but it definitely looks pretty powerful, being 4 of them there. Another neat thing is the crystal centered on the middle of this right here. It's a pretty high clock speed, 67 megahertz. A lot of processing power going on. Typically you only see stuff in the 16 to 24 megahertz range on these older pieces of Roland gear. To the right over here we actually have our DAC. It's the NEC D63200. We see this in a lot of Roland gear. It was in the XB50. I also believe it was in the MC303. This is a dual stereo 18-bit DAC. Pretty good specs. A nice component for the time. Moving over to the left side of the board, we have the main processor. This is typically a Hitachi-made chip there. HD641300-2FP16, so most likely 16-bit. Has its crystal right next to there to it as well, 16 megahertz to run it. And then on the left side of the board, we have a couple other chips over here. So most likely this here is the actual ROM that runs the operating system for the unit. Maybe flash, I'm not entirely sure. And then you've got what looks to be some RAM tied to that next to it over there, just for the actual operation of the unit. Another thing unusual for this Roland board is that there's actually some components in the bottom. You typically don't see that on a lot of Roland gear. Specifically just some glue logic down there, but this is what looks to be a DRAM. It is a TC544260 DJS-60. 60 gives it away, the dash 60 gives away that it most likely is a DRAM based on that. Probably 16-bit as well, although I'll have to look at the specs. Another chip over here. I can't read the number on it though. There's like some type of conformal coating or something on the bottom side of this. Possibly from the reflow process, I'm not sure, but making it hard to read. Anyway, JP-8000 labeled mainboard, so this was most likely used only on the JP-8000, no other synth, which you also see a lot typically on Roland gear. They would make a single board for only that synth and wouldn't share it among anything else, just due to the uniqueness of that. Although I would be curious to know if the JP-8080, the rack mount version of the JP-8000, used the same board or not. Okay, JP-8000's back on the bench. I have the board reinstalled, all the wires hooked back up, all the shielding back in place. Something interesting too about this, the shielding is usually a lot more aggressive than I find in a lot of Roland gear. It's completely wrapped. You have foil, like a foil sheet all the way around the bottom that wraps the board, and this big metal cover on the top that's all bonded together and grounded together as well. So they must have had some type of issue with the emissions coming off of this board, in terms of interference, the amount of RF coming out of here that could be potentially, exceed whatever specifications, here in the US you would have in Japan for that matter. So they must have put the shielding on here just to kind of suppress that, keep the noise down. A lot of ferrites on here too, big ferrite beads across these cables, a lot bigger than you typically see as well. So just kind of an interesting note. So one additional thing you want to consider is this board here, the jack board on the back. This board has a couple little amplifiers that actually run your left-right audio outs and your headphone out, and there are a handful of capacitors on here too. These are through-hole electrolytics, Sanyo branded, 85C rated. You're going to want to replace these two, just out of precautionary. I have seen these also cause low audio issues, and you're in here, you're right here, you might as well replace them. That will guarantee, basically getting another 30 years of life out of this unit, because even though they're not on the same board, this entire unit inside gets hot, both from the power supply and from electronics itself, and that heat over time is what starts to deteriorate these. And they're not that high quality of a cap to begin with, which is the reason why they start to fail and contribute to your low audio output. So I'm going to pull this board out and we'll replace the electrolytics on here. Alright, all the electrolytics on this board have been replaced. Again, Panasonic FC series, 105C rated. 3 values on there. There was 10 microfarads, some 47s, and a single 100. So really common values. Secondly, power supply caps. We'll take a closer look at the power supply in a second here, but again, the power supply on this is a linear supply. It's got big heat sinks on it. I mean, this entire frame is basically a heat sink. It typically doesn't get too hot, so these caps I typically find in the power supply are not a problem at this point in time. But to be extremely thorough and absolutely guaranteed to get another 30 years of life out of this, go ahead and replace the power supply caps too. There's probably 5 or 6 of them in there. A couple larger values, but again, replace them with 105C rated caps and you'll be good for a very, very long time. Let's take a look at the transformer for the voltage conversion. So here's the main transformer for the JP-8000. On this side you have your primary, this side you have your secondary. So these two are coming from your main voltage in on the back here through the IEC power connector, common mode choke, a couple capacitors as well, just for filtering some noise, in your power switch. So the primary has multiple taps, and they're actually labeled for the different voltages that are coming in. So 0 volt is your neutral, then there is no connection on the following pin. Then you got 100 volts, 120, 230, 240. Because this is a Japanese unit, you'll notice that the hot line, or the hot wire coming off of the power board here, is tied to the 100 volt pin. So to convert this to US voltages of 120 volts, I'm going to remove the lead from there, solder it on there, and we'll be done. There's no fusing in here that needs to change. There's no other components in here that need to change because the voltage difference is so minor between those two. If you needed to convert this to 230 or 240 volts, a lot would change because the specifications of some of these caps over here may be different. This board may even be completely different itself, since you would have a separate or a different input connector for the 240 volt power in many applications. The reason you have to do this is because since this is a linear supply, when you're running 120 volts in on the 100 volt tap, you're going to get an equal ratio of voltage increase off the secondaries here, which feed down to the power board, which is a little bit lower in the unit. On that you have your regulators. Typically you'll have 3. You'll have your 5 volt regulator, which runs almost everything on here. And then you'll have a plus or minus 15 volt regulator to run the analog circuitry, your op amps, your DAC, things like that. That higher voltage AC coming off here may exceed several things. It may exceed your bridge rectifiers in terms of their voltage. May not exceed it on those, but it could get closer to their maximum specifications. Unlikely. Your bigger issue is the caps. The caps are going to be rated for a certain voltage, and with that voltage coming off there, the caps are going to be running a lot hotter, and then the regulators too are going to be running a lot hotter. They're going to be running a lot higher towards their upper limit of the input voltage in there. Truthfully, between the Japanese voltage of 100 and the US voltage of 120, you could probably actually run these on 120 and it will be just fine, but it's not worth the risk because you can easily just make this adjustment by moving this wire across from that tap to that tap. Again, to actually verify if this would run 120 safely, you'd have to go through, look at all the specs, all the different components, make sure they can all handle the additional AC voltage coming off the secondary, calculate what that is, or measure it, with your meter, etc. So it's just safer to make the change. So I will do that here shortly by moving that tap from there to there. Alright, so change is complete. I've got the hot wire coming into the 120 volt tap instead of the 100 volt tap. So this change is complete. We can put this unit back together and test it out. So I've got the JP-8000 back upside down on my bench for testing, but I'm still not getting any audio, which doesn't make any sense. We should have audio at this point. So something's wrong. Now through the headphones, I do have faint audio through the headphones like it was before, but no audio out the main left and right. So I messed something up. Or there's something else wrong, which is unusual. The caps usually always fix this. Let's flip it back over, take another look, and try to figure out what's going on. Okay, so the question is why is there still no audio? So we have weak headphone audio, which is what we had before, but we still don't have any audio of left and right outputs, which is very, very odd. Typically, like I mentioned, the caps resolve this issue. I've done all the caps on the digital board plus the analog board here in terms of the output board. Next thing I went is, obviously back on the bench here upside down, I checked the voltages, because I never did that to begin with, because I had no reason to, because everything was working, just audio was weak. But I verified it anyway. I've got 5 volt on the digital rail, and then plus or minus 15 on the analog rail. And I measured that all the way to the the digital board there. Voltages are good. So next step I started doing was actually scoping the audio to see where it's stopping at that point. Secondly, I grabbed the service manual for this and pulled the schematic so I could actually follow the circuit and see what's going on. Where I'm at right now is I've got audio basically coming in. So it does a couple things. The audio actually comes in this board from the digital board here. It jumps off of through this connector and then comes back into this board. It's doing something down here, I'm not exactly sure. I'd have to follow the schematic on the board to see what it's doing, but it doesn't matter. So I have audio back here. So I've got the synth on right now, and the arpeggiator's on, that's just playing a couple notes. So if I probe it, I can see, I've got my audio right here coming into this board on the left and right channels. And these are on caps C34 and C35, both of which that I replaced. So I know I've got audio left and right channel coming into this board. So through that goes through a couple op amps, which are a part of this chip right here, which is IC4A. Well, IC4A and IC4B make up both of those op amps. And then it exit there through C22 and C23, which I have right here. And I verified that I have audio with a little bit higher amplitude, after it goes through that op amp on both of those outputs right there. So I know that that's good. Next step it goes through is R40 and R34. Probing those, R40 right here, I've got audio on one side of R40, and then I have nothing on the opposite side of R40. So the question is what's happening to the audio passing through R40? I tested the resistor, it's good, 1.5K, so no issues there. So the only thing remaining after the circuit, which is right here, which is actually pretty obvious, is that this Q1 through Q7, well Q1, Q4, Q6, Q7, this group of transistors right here, it's a muting circuit. So there's a muting circuit that mutes these during power on, during power off to limit the thump you get during those states. So what's happening is that for some reason the muting circuit isn't turning off. So Q1 and Q4 are basically grounding the output of R40 and R34 of those audio pathways through the left and right jacks out the back. To test that theory to see if what it is, I trace the schematic over, and the muting circuit comes in on CN1 on pin 2, and that's what turns those transistors on, which is this connector right here. So what I'm going to do is I'm going to pull this connector out, lift pin 2 basically on this ribbon cable and plug it back in, and then we'll test and see if we actually have audio through our left and right outputs. Okay, muting circuit is lifted. I've just got that pin lifted right there. So we will turn it on. We had an audio thump, which is a good sign because that indicates the muted circuit doesn't exist and it's there. And we have audio. I bet you probing this now we will have audio on either side of those resistors. Input and the output, which we do on the scope there. We at least know what the issue is. It's a muting circuit. For some reason the muting circuit is not unmuting the transistors that run the muting circuit on the jack board here. Next step will be to figure out why. So I have the board back out. I think I may have found my mistake. So I found the power on circuitry. I'll show the schematic in a bigger view here where it is. But basically it's a simple turn-on delay that's based around this cap, which looks like C219. In the schematic this is supposed to be a 22 microfarad. I mistakenly put a 47 microfarad in here, which part of me doesn't want to believe that would be enough to cause this problem. It should just increase the turn-on delay, but it's still not the right value that's in there. So while I'm in here, I'm going to remove that cap. I'm going to inspect the rest of this area a little bit more closely, make sure there's no solder bridges, anything like that. Because essentially what's happening is that power on delay line that's going out to the jack board is staying high. It's not dropping low. It's supposed to drop low because when it drops low, those transistors open and the muting circuit is disabled at that point. So I don't know why it's holding high. So I'm going to start by replacing this cap, and then we'll go from there after inspecting the rest of the circuitry. Alright, so I replaced that incorrect 47 microfarad cap with the 22 microfarad. Reassembled all the board, got it all back in, and we'll power it on. Takes a second for it to boot. Load the OS anyway, and we have audio. That cap was the problem, which was my fault. There was actually nothing wrong with the muting circuitry at all. I just screwed up and had accidentally replaced the cap with the incorrect value. And looking at the schematic, that is part of the muting circuit, and for whatever reason, that cap has to charge, which then basically triggers the transistor to then, unmute the synth, and that cap, for whatever reason, it wasn't charging, therefore it wasn't unmuting, it was stuck in the state. At this point, it's working. The repair is done and complete in terms of the audio issue. Like I mentioned before, it was primarily all the electrolytics on this board. As a precautionary measure, we replace the electrolytics on the jack board as well. It's typically not necessary, but while you're in here, you might as well do it. No reason not to. The last thing is if you want to, you can replace the caps in the power supply. I'm going to myself, just because I'm in here and I've already spent this much time with it, to do the remaining, I think there's 5 caps on the board, just to guarantee that all the caps are replaced on here, and give you, another 20, 30 years of or more of trouble-free operation, since, you're actually replacing the caps in here with better caps, 105C rated caps. One final thing I'm going to do too, and it's strictly just because the key bed is so easy to pull out on this unit. I mean, there is seriously just looks like about 5 screws and the 2 ribbon cables. I'm going to pull the key bed out and actually clean the keys on it. Just, it's easier to do when the key bed is out of it. Just get all the grime and dirt out of there, and that'll be it. So I may or may not film some of this, depends how long this video is running. I've pulled key beds out in many other videos. There's really nothing to it, and replacing the caps on a power supply is trivial at best. While I was going through this key bed, I noticed I actually have one key that's sticking a little bit. So E here, for whatever reason, is not turning up all the way, which is odd. I'm going to pull this key out. There's grease under there that lubricates it. The key bed on this is a little bit different from the key beds too. It doesn't have typical Roland springs. There's actually a little spring right underneath here. And to remove the key, you actually have to pry it apart at the back here, and it will slide out forward. So it's slightly different than most of the older Roland synths in terms of the way that they're constructed. So key came out just fine. That grease in here that I'm talking about. Reinsert the key. Okay, they look to be good. All I did was kind of wipe the grease off and kind of re-spread it around. And we seem to be okay. So that's good. The best way to clean these key beds is to pull every key out and clean every key individually. You have to do that when they're really nasty, because that's the only way you can get down the sides and really get in there and clean it. But this one's not too bad. It's just when it's in the synth, it's hard to get this very back area here, and usually end up with some noticeable dust and dirt back there, which I noticed a little bit in this one, but again, it wasn't too bad. You see the stuff coming off there. So this concludes this repair of the Roland JP-8000. Like I said, it's a common repair. You're going to have to do this to pretty much every JP-8000 in existence, because they all suffer the same problem. So hopefully this was useful to you. If you do repair, just make sure you use the proper values and you won't run into the issue that I came across during this repair. Use good components, 105C caps, always. And with proper care of these things, I mean, I think it's going to be a future classic. I mean, they're at a price point now where, they're pretty affordable, usually right around $300 or $400. So thank you for watching.